one, when you've got two different functions, what's really good about this is you only actually have to integrate once if you do the bigger one minus the smaller one. Because what happens is if, for example, this is between 4 and 2, if we imagine, how can I color code this? If I say area 2 is this one, and I say that's the top function g of x integrated. So area 2 is the integral between 4 and 2 of gx with respect to x. And area 1 is the smaller one under this curve, which is the integral between 4 and 2 of the f function. Then the area between them is area 2 minus area 1. Okay, so basically find the area under each curve and subtract them. Now, what we can actually do, we could do that as two separate integrals. But what you can actually do is just do the integral of the above one minus, so work out that function minus that function and then just integrate it once. I wonder if people have seen that before. This is really quite helpful. Rather than doing two integrations, you can take them away from each other and just do one combined integral, if that's the case that we have, if it stays above it for the whole time. So it's a really, really good one to do. And we're going to push on to some slightly harder questions of this now. What I'd like you to try is this one here. So if you've got the area, you can do them. If it's easier as two separate integrals, by all means do that, especially if you don't know how it looks, and then just take them away. But it says calculate the area between two curves. F of x is x squared plus 2, and g of x is 1 over x plus 2 all squared. Between 0 and 2, you should show all your work in and leave your answer as a single fraction. Okay. So let's have a little look. 5 marks. So there's quite a lot going on here. 5 key steps, probably 2 for each integral and 1 mark for putting it all together. Can't just plug it into a calculator. There's your graph. Are you given a picture of the graph? I think you are. So I'm going to give you 2 minutes to try it. And then I'll maybe just try and start integrating it. And then I'll catch up with you and see how we're getting on. Really well done, guys. You're doing great with the perseverance here. It's just like full on calculus this afternoon so far. Really well done. Really appreciate it. 2 minutes and I'll check back in with you guys. Well done. Okay, so another minute or so, just maybe 40 seconds, and we'll start going through it together. Well done if you're almost there or you're kind of getting somewhere with that. That's brilliant. Next thing we'll focus on is first order differential equations. So we're hitting all the big topics here, but as I said, doing really, really well. So let's keep going. Okay, so we'll start going through this together. There's the graph that hopefully you've been presented with. And so the area under the first curve, x squared plus 2, hopefully not too bad. The bounded integral between 2 and 0, which many of you, your calculators will do, and it was almost like a year 12 style one. Just be careful, like leaving it exact stuff. So that's what we've got. And then we need to do the integral of g of x. So, sorry, finding the area under the first one, actually subbing 2 and 0 in, and we'll get the following 20 over 3. Check you got that, because that would definitely be worth 1 mark, and a mark for working as well. So as we said, it's probably 2 marks for each area, and then a final mark for putting it all together or doing a subtraction and showing that. And you may even get that final mark if one of them's wrong, but you showed that step. So the second curve, the integral, this isn't an ln one, this isn't ln because it's squared, it's a reverse chain. So this would become a minus 1 over x plus 2, because it's like x plus 2 to the minus 2. So that's the one to be careful with. And then again, we're subbing in the bounds of 2 and 0. So for this one, if we sub 2 and 0 in, we get a quarter. We're all happy with that? So just check. Now, I think that was the harder integral. So just going back, because I'm worried that was a bit quick. This one we've got to be really careful with. It's not ln. This is actually hard. The first one was very like a year 12 style, and hopefully we got those 2 marks. This is like x plus 2 to the minus 2. So the guess is power it up by 1, so x plus 2 to the minus 1. And if you differentiate that, a minus 1 would come down, and it would be minus x plus 2 to the minus 2. So it's off by a factor of minus 1. So the actual integral to this is this thing here. And I'm aware that this might be the harder bit. So please check that if that's affected you there. Because I know we can sub bounds in and I know we can tidy it up, but this is probably the pinch point of the question. Okay, so then you sub 2 and you sub 0 in to that. And so at that stage, you would have minus 1 over 2 plus 2, minus, be careful with all these minus signs as well. It's only up to a quarter. So we've got the 2 separate areas under each of the curves. And even looking at your graph, guys, remember that that other graph that's near the bottom, it's got a really tiny area under it. So it probably looks right that that's a really small fraction. So then when you take them away from each other to get the gray area in between, we're left with this as our answer. So feel free to make a note, even if you need to rework it or check. But what we'll do is we'll push on if you're happy with that.